Here's a second example on graphing an exponential function. So we have the g of x, which is the child function, and it's 1/3 times 5 raised to the x power. So the parent function is a base of 5 raised to the x. So let's just go ahead and find those ordered pairs first. We evaluate the function for -1, 0, 1, and 2. So 5 to the -1 power, 5 to the 0 power, 5 to the 1 power, 5 to the second power. And then we simplify those numbers, and we get 1/5 1, 5, and 25. And then we write those as ordered pairs. And then we graph the parent function. What happens with the 1/3 right there is a transformation, which we call a vertical compression, because it's a fraction, it's a multiplier, it's a scalar multiplier, by 1/3. So we don't have to move this function up or down. So the asymptote is the same as its parent function at y equals 0. Also, the y-intercept, I'm just going to label this one, is over 0, up 1 on the parent function. So now we want to find the y-intercept of the child. So again, this is our g of x function. We want to find the y-intercept. So what we do is we evaluate the function for 0. So g of 0. So we get 1/3 times 5 raised to the 0 power. Anything raised to the 0 power is 1. 1/3 times 1 is 1/3. So as an ordered pair, it's over 0, up 1/3. So there's our new y-intercept. What will happen is this exponential function will be compressed vertically by 1/3. So each of these y numbers right here will be multiplied by 1/3. Now on our assessments, we're not going to require you to graph a complete sketch of the child function. And then the domain of the child function is all real numbers. And then the range of values is everything greater than the horizontal asymptote at y equals 0. Example 3, write each transformed function. So we have the parent function of f of x equals 4 to the x power, and we want to transform it by reflecting it across both axes and then moving it down 2 units. So to reflect across both axes, we're going to have a negative in front of the function and then a negative up in the power. The other thing is moving it down 2 units. So when we move down 2 units, that happens at the end of the function. So -2. Second example, new parent function, our base is 5. And now we're going to vertically compress it by 1/2, so that's a multiplier. That happens in front of the function. Then we want to reflect it across the y-axis. So that happens up in the power. So I'm just going to erase that. So it's going to be negative x. And then the last thing is it's going to move right 7 units. Again, that happens up in the power. So we do opposite. It's going to be x minus 7.